All right, it's my pleasure to present to you guys Kishore Jalleda.
That's a pretty good turnout. But anyway, my name is Kishore Jalleda. I run the operations team at Imview. I've been with Imview for about 5 to 6 years now. And I'm here to talk about how we actually do Nagios in what we call the continuous deployment and the Agile and the Devops world at Imview. How many people here have heard about Imview before? Nobody? Wow. Okay. So Imview is it's a avatar-based social entertainment destination. It was founded in 2004, and if you look at the slide, you can actually see everything is really an avatar. You can do things like you can shop around, you can meet new people, you can dress up your avatar, and so many other things. I don't want to spend too much time on what this is, but I mean, for the purposes of this presentation, I think it's okay to say this is an avatar-based, social entertainment destination. A little bit more about Imview. We make about $50 million in revenue every year. We have more than 100 million registered users, and we also have 10 plus million items in our virtual catalog. If you go back, for example, this is actually one of our catalog that you can actually see from within our client. It could be your dress, your top, shoes, whatnot. The reason I'm here, again, as I mentioned before, is to, if you look at the overview of my presentation, I do talk about Imview and continuous deployment. How many people here have heard about continuous deployment? One. Okay. Where did you hear it? I'm just curious. Okay. Anyway, I think what you need to understand here really is what exactly is continuous deployment. If you look at this slide, the biggest thing that really stands out here is the ability to push code to our customers 50 times a day. It's almost like doing the impossible. And continuous deployment is real, and Imview has actually been one of the pioneers of continuous deployment. The way to understand it is there's different infrastructure that actually makes up continuous deployment. The first thing is you have a bunch of tests that run each time you actually commit something to your Subversion. I'm assuming people actually use Subversion here, but anyway, so that's like phase one. Phase two is you actually have commit hooks which can prevent you from doing something bad. The next thing, what we call as continuous deployment, is again based on how we actually do something like the tools which we use to push out code to our website. Then we also have phase four, which is of continuous deployment again, which is again based on what we call as the 5 why process. I'm going to get into more detail about that, but again, if you're for the purposes of this meeting, just assume that it's a root cause analysis system that we use to make sure that things don't go wrong. So that's briefly about continuous deployment. So just to recap, you have a bunch of tests. Each time you commit something, a bunch of tests run, and then assuming the tests pass, only then you actually push to the website. What does this mean? The ability to push so many times to your customers could mean a lot of things. First thing is things can change all the time. New features add up instantly. And there could be failures that could cascade rapidly. and things can fall through the cracks, and several other things that you may not experience in a traditional software organization. What you really need to understand here is, before we dig deep into how Nagios is used at IMU, is to give you some insights into how exactly Nagios is used in a traditional, in a continuous deployment shop like IMU. So, a short overview. We use Nagios 3.2.0. We have about 800 plus hosts. We have about 18,000 plus service checks. And everything is based off a single Nagios instance. It has 8 cores and 8 gigs of RAM, pretty much. Before I completely explain to you how Nagios is used at IMU, I'm going to take a couple of minutes to explain how new checks actually get added to Nagios. If you look at this slide, it talks about the server lifecycle management, which in my opinion is the primary job of operations, being in the operations team. So if you look at it, you purchase a server, you do, actually we at IMU use fully automated installs to push and to push configs and push out the operating system. Where Nagios fits in is at a phase where you actually have to add monitoring and alerting, correct? And then you have we also run CF engine, production, and decommission and things like that. Before I explain to you how we add checks or services to new hosts, what I'm going to do is give you a bit of background into how operations does continuous integration and deployment. We built something internally, what we call as the asset database. It's essentially used for tracking your assets, like servers, which is again essential for the lifecycle management. If you look at it, it's again built internally by IMU. It's a simple but powerful concept. What it has is it's got a class. It has information on the class, the role, tags, and attributes. For example, you could have a server which belongs to the class MySQL. It could have a role which says it's a customer shard, which means it has a specific role belonging to a class. It could also have a tag which says available, which means if you wanted to get the list of available servers from your production environment, you can actually just run a command, and you should be able to get that information. So our end goal here is again to build everything off the asset database. It is again the source of truth for everything that is asset related. For example, if somebody wanted to know what is the master in a master slave MySQL setup, that information is actually stored in this database. So it is, and a lot of configs are automatically generated based on this asset database. What you'll be looking at in the next slide is, again, we're talking about how new hosts get added to Nagios at IMU, okay? And the theme again here is operations and continuous deployment, which is to make things more agile. So what happens here? All we do is we just run a command. It's called generate nagiosconf.pl. Our operations team loves to code in Perl. And what it does is, based on the information from the asset database, which was entered when the server was put into production, files like hosts.cfg and hostgroups.cfg are automatically generated. If you look at the specific example, you can actually see that this is a host. It has a host name. It's a pretty generic notation that we use. What is most important here is the host groups. If you look at it, this host, AF001115, belongs to a lot of host groups. So when let's assume there's a specific check that is specific to a host group, this host is automatically going to get that service check. The service check could be, you name it. I mean, load average, CPU. I mean, if you just talk about the generic checks, it does belong to a whole lot of host groups, and that is for a reason. Again, this would ensure that none of your service checks which should run on a host are ever going to be missed. So that's step one. So we generate the configs. I'm assuming people use some kind of a repository. We use Subversion. Anybody here who don't use as a repository like for maintaining the configurations? Just curious. Great. What happens after that? We commit the file. Now, a bunch of things happen here when you commit the file. Specifically, because I remember I talked about continuous deployment for engineering department, and it's essentially each time you commit, there's thousands and thousands and thousands of automated tests that run, which ensure that your features or code is supposed to be, is doing what it's supposed to be doing. The same thing happens in operations. Again, this is kind of with the DevOps philosophy where engineering and operations work hand in hand, and you learn a lot from the engineering team. So each time you commit, if you look at this graph, what it is telling me is that at 1326, somebody called T. Reed committed something. Something that says aggregator is the one which aggregates a bunch of results from different build slaves. The distributor is the one which distributes all the tests amongst different, what we call build slaves. So if you look here, there's operations 1303, 1304. So all these are build slaves. And we have about, 400 or so automated tests that run amongst all these build slaves, and then you get the results back. What is really cool is that you can have some intermittent tests. For example, let's say there's a test which has to connect to Memcache to get a key. Let's say the Memcache was not available during that time. That test is going to fail, but that's only an intermittent test. What we did was, specifically with help from engineering, is we said, okay, if a test fails once, please run it on a different slave so that maybe it's going to pass again. So that's what if you see there's a column which is red because it failed on one slave, but then that test ran again on a different slave, and it actually passed. So great. So this build was actually successful. Now you may ask me, what are all the tests that were written here? A simple test could be, how many people here, once you push out an updated Nagios config file, how many people actually here run the syntax checker, which actually tells you that your syntax is OK? Great. That is awesome. We all do that, right? We used to do that in Imbue. But you can actually write that as part of a test, which means you don't have to do that manually. That test is actually run in your build environment. So it's a simple example of a check which actually runs. So each time you push, you have a high degree of confidence that you're not in a situation where, OK, I pushed to my Nagios host. Oh, damn, there's a syntax error, and Nagios doesn't want to start. And then there's no production monitoring for 10 minutes. That's bad. It'd rather happen in your build environment. So that's again, we learned this from engineering. So that's a very simple example of a test. Again, if there's logic in your scripts or your checks, you can write tests for it. You can use, I'll get into this into more detail a little bit later, and you can always ask me. Feel free to interrupt me with any questions you may have, but that's what happens here. So we auto-generated the config files, we committed them, and a bunch of tests ran, and what do we do now? We push to the actual Nagios server. In our case, pushing it is nothing more than running. How many people use CF Engine or CF Agent here to maintain their configurations? So do you guys know what CF Engine is, CF Agent? It's actually an auto, it's a automatic configuration tool, and you actually write some rules for it, and each time you run a command called CF Agent, it's kind of like Puppet, if you guys are aware of it. It's automatic configuration management system. So at a high level, it runs CF Agent. Think of it as it's a bunch of shell scripts which get your configs from a central repository. At a high level, that's what it is. It's a way to maintain configurations which are scalable, maintainable, deployable, and things like that, all that good stuff. So what this does is this ops push, is short for operations push, is something that we built at InView. The most important thing that this does is if you look at the previous slide, this build was successful. So this tool actually checks if your last build was successful, and only then allows you to push. If the build failed, it's going to say, hey, your build failed, so something is wrong. I am not going to push this to production. So that's a safety net that we have. So now you may ask, okay, so there's a P1, or there's a priority 1 issue, which I'm going to explain again in detail a little bit later, and then I have to push to my to my Nagios host or whatever, and this build system is not letting me push. So we have an option which says on-call override. It's just a flag. What that means is that maybe one of your thousands of tests failed, and then your change was not related to that test, and it is okay to push in that situation just because you know that it is not going to negatively impact production. In that case, it's okay to push, and then you just give it that flag. What that does is it's going to page on-call, whoever the on-call person is, and let him know that, hey, there's a change that is happening. And there's also an option to push the last green revision, which means, for example, if two of you committed at the same time, your test passed and his test failed, I still want to push out my changes so in that case, I'll use his last green revision and not the latest one to actually push out my changes. So only that your changes will go out and not his changes. So that's how we push to production. That's an important part of the continuous deployment is, again, simple tools which let you push from your continuous integration, which is, again, your build infrastructure and the tests and things like that. I'll be repeating these words a lot during the presentation just because that's the theme of the presentation. Some of this may seem radical, but again, all this is real. Continuous deployment is real, and it just works out great for us. Great. So we talked about how new hosts get Nagios coverage, right? Next, another important aspect of continuous deployment and DevOps and being agile is that a lot of new features are always adding up. There's always like something happening. There's always sprints, Scrum process, and things like that. If you look at the slide, it kind of explains to you the typical way new features or products get released to customers. I'm not going to go into detail for everything, but there's an important thing what we call as the technical design document. And for every feature or product that's being built, the engineer has to write this. That technical design document, the main goal of that is to get into as much as detail as possible, so that not just the person who wrote it, anybody should be able to look at that document and should be able to complete the project. One of the things that the technical design document has is the monitoring alerting section. You could imagine, you're building a new feature, you want to understand how your feature works, correct? So that's where, like, if you look at, like, that's the third box. This is an actual example of a technical design document. If you look at the monitoring section, it talks about, okay, I'm rolling this feature out. Does it need any new Nagios checks? And the engineer says, okay, I need the following. It's it's probably based on counters. It's probably based on, like, simple features, like, is the game playable and things like that. I'm not going to go into, like, every single detail of this, but I mean, at a high level, what you need to understand is there's an engineer when he creates, or a developer, if you wish, when he creates a technical design document, there's a section which says specifically what is the operations and monitoring and alerting requirements needed for that project or that feature. Now what happens? That request comes to operations, and then we ask them, okay, how often does this alert needs to run? Or if it's when something goes off, whom should it be paging? We all have done this, right? I mean, as part of Nagios, you have to fill in those things when you actually deploy new Nagios checks. And then what happened is there was this communication going back and forth between the operations team and engineering team, and they said, well, this is not a very good use of our time, and this is not in sync with our philosophy of being agile. So we said, okay, let's create a template form and have the engineers or the developers fill it out and give it back to us, so that any operations person can just take it and deploy the check. So this is an example of a request. You can actually see, I mean, I'm not going to read all this. You guys can read it. But it's a very good thing that has optimized that communication flow between the operations and engineering teams. Great. So we talked about how hosts get new Nagios checks. We also talked about how new features get Nagios checks. And the last thing I was going to talk about how new Nagios checks are added was, again, for our data team. Again, I mean, I'm sure all of you are like aware of like the whole like big data Hadoop thing going on these days. But again, I just put in the slide in there just because Nagios is also very useful for a team like data, just because data fresh with all that data explosion. Obviously, you have like your ETL jobs and data warehouse and all that. All those need to be updated in time. So it is critical that you have some monitoring and alerting that is telling you that hey, something is broken, and you need. There's actually somebody working on it, because the last thing you want is like your CEO calling you on a Saturday, finding out, hey, what's up with this? I need to push out this new campaign, and I don't have my data. That is a pretty bad situation to be in. So that's where I think Nagios is invaluable to actually monitor anything. Actually, simply put, if you can measure something, Nagios will do monitoring and alerting for you. So which is great. Great. So we talked about continuous deployment. We talked about Imbue. We talked about continuous deployment and the infrastructure behind continuous deployment. We talked about how new Nagios checks are added to Imbue. We talked about how new Nagios checks are added as part of new product releases or new feature releases. We also talked a little bit about the data team. Now, what is Nagios really good at? Anybody? What does Nagios do best? I'm sorry? Spend? Spam? Okay, that is a very good answer. And I'm actually going to talk about that actually in my slide. There's 11:50, right? So again, that's an excellent answer. And there's a solution for that. You can actually tune Nagios to not spam you. I think, in my opinion, that's the human element of monitoring. I mean, I think Nagios as a tool is beautiful. I think it does what it's supposed to be doing. But you need to put in some effort to make sure that it doesn't. But anyway, what I was trying to get to was that things will fail, right? Things will eventually fail. There's no question about that. And things do fail at Imbue, or especially at Imbue, just because so many things change at the same time. I mean, can you imagine there were 30 changes that went out the same day, or 50 on a very good day, and you're trying to figure out, hey, what actually broke this specific thing? Because there were 5 changes that happened in the last 5 minutes. So you get into situations like these, and then you need to evolve and adapt to the fact that so many things can actually change at the same time, and tune your monitoring and alerting in such a way that you can actually catch and prevent those failures ahead of time. So let's see how Imbue does it. How we try to prevent and catch failures, because obviously you would want to prevent failures, and then if failures do happen, you would want to catch them soon enough so that you can actually react soon enough, so that you can actually get your site or whatever your service is back up as soon as possible. So again, local acceptance test is something that engineers or developers run on their sandbox. That's safety net number 1. Assuming things go good, then it goes to the next level, which is our hypo builds. I talked about build bots, essentially a bunch of machines, distributed machines, actually VMs, running a bunch of tests. It's open source software, build bot. It's nothing fancy. Hypo builds is something that we created just because if there's really big changes, let's say you're pushing out a new memcache version to production, and you want to test that. You don't want to be pushing, making those changes on your build slaves just because if a slave goes red, you cannot push. And we hate, developers losing their productivity. So what we just said was, if there's huge changes like these, let's say you're upgrading MySQL from 4.1 to 5.5, and you have 2,000 tests that connect to MySQL, automated tests, of course. You would want to run that separately in parallel with the builds so that you don't stop or you don't block developers. That's what we call as hypo builds. Then we have buildbot, of course. I talked about it in large extent. And then what is more? I mean, if you recall, like what I talked about continuous deployment in the beginning, I talked about something called the cluster immunity or the cluster immune system. I think this is a critical component of continuous deployment. Why? Just because, again, so many changes happening at the same time. You don't have a QA or anything, so you need some kind of an immune system, automated immune system. You can also call it automated push monitoring and rollback, which can roll things back for you automatically based on some critical metrics. So this is how we do it at Immu. So developer pushes out a change, and the change is actually pushed to a small % of the servers. And we monitor pre- and post-push metrics for that change. And assuming things are good, we push the changes out to the rest of the servers. And that is like phase 2. And we check again if the pre- and the post-push metrics are within certain limits. The delta shouldn't be big. For example, if the load average on a machine jumped from 1 to 1.5, I think that's okay. I mean, I just gave a stupid example, but again, I'll give much better examples. If that's okay, it goes to phase 2, and then you actually push out your change, and you can actually see your change live. The whole process takes about 10 minutes. So if you want to make a change at Immu that your customers can see, like millions of people can see, it takes about 5-10 minutes. That's it. So you commit, you test pass, you push. And then you have the cluster immune system. Of course, you can get rollback as well, if something went bad. Great. How does the push status page look like? Remember I talked about phase 1, phase 2. I just took a screenshot of a phase 2. If you look at the screenshot, what is most interesting here is we just don't monitor server-specific or host-specific metrics. We do monitor those, but we also monitor things like registrations per second, revenue per second, logins per second, new users created per second, number of games played per second. In this specific example, if you look at here, the number of registrations actually jumped by 21 pre- and post-push. So it's okay. So your change did not impact registrations, which means people were still able to register every day. Remember, we have 100 million registered users, which means every single day we get about 40 to 50,000 registrations, which means there's a registration every 1 or 2 seconds. So it is critical that and people are constantly coming into our funnel. So it is important that we have something like this that can automatically roll back a bad code push. This was an example of a good code push, but I mean, assuming things went bad, you would have automatically rolled back. And the way we do it is a simple symlink switch, symbolic link. I mean, you guys all know symbolic links. So we maintain like multiple revisions of our website on our web servers, and then all it does is a simple symbolic link change, and then that just automatically rolls back your changes. Great. Now we talked about things will fail. We talked about like how Immu tries to prevent failures. If we actually go back to the previous slide, assuming things come to the Nagios level, that's when, that's when you know that it's a priority one. How many people use P1 to define that there's an issue with their website in their companies? Nobody? Okay, that's fine. I think it's a Silicon Valley thing. I don't know what it is, but we said P1 just because it's a priority 1 issue, which means it is an issue which is actually impacting live operations. But anyway, if you go back here, I'll spend about 5 minutes trying to explain what P1 is and what Nagios does. A P1 again is something which is a priority 1 issue impacting live customers. What are different phases of a P1? You could have the first phase again is the identification phase, correct? Which is like we need to know if there's a P1. Somebody you need to understand like if there's a P1, and I think this is where Nagios comes into play, which is actually telling you that hey, there's a P1. It could be like your site's down, people are not able to chat, People are not able to play games, whatever. The second phase is the communication and declaration phase. So this is where people like the operations team and people like you guys, assuming you guys are sysadmins or operations, try to communicate that there's been a P1 to the rest of the company. This is important for several reasons. Just to give you an analogy here, let's say your toilet is actually clogged at your home. What do you guys do first? Anybody? What is the first thing you do when your toilet is clogged at work, at your home? Use a what? So you try to fix it yourself, right? What is the other approach? Like, what else can you do? For example, if it was me, the first thing I would probably do is I would put like a board, like something in there that says, hey, do not use this anymore. At least so that you don't exasperate the situation more. So that's where communication comes in. So one of the things that we do at IMU is, and it's just part of the culture, is when there's an issue, before we dive into the problem and try to solve it, we communicate it to the rest of the company so that people actually know that there's a problem. For example, you could have pushed out a change, and assuming there's an email that comes out, you actually know that, hey, production is having issues, because you as the operations team, being the first line of defense, would be the first people to know that information. And you have that information which nobody else in the company has, correct? Just imagine your customer service. They would want to know that information because customers would start calling them and say, hey, I purchased this product. How come I don't see it in my catalog or in my homepage? So that information is critical for people to know. So that's the communication phase. You communicate saying, hey, there's a P1, we're working on it. And then the actual resolution, this is where all you guys come into play, and the operations people, and they use their experience and super troubleshooting skills to actually resolve the problem. And then you have the postmortem, or the 5 why process, or the root cause analysis. Number 4 is again one of the components of continuous deployment, because things fail, right? And then once things fail, I think it's okay to fail, but what is more important is for the critical stakeholders to get together and run something called a root cause analysis, or the 5 why process. How many guys have heard about 5 whys before? Great. I think Toyota used to do this at their production assembly lines, but again, 5 why process is pretty big at IMU. And the final phase again is the P1 follow-up, which is again, you go into a meeting, you talk about stuff, and then you say, okay, we'll do these action items to prevent future failures. I think it's worthwhile talking a bit more about the 5 why process. One of the things that at least we at IMU have a culture is of running blameless postmortems, or blameless 5 why process. So let's say you pushed out a change to the website, or whatever, to your service, and it's down. There's no finger pointing. There's no say, hey, there's nothing stupid going on. It's all about, the only goal is how can we prevent this failure from happening again. So there's this awesome culture of actually running blameless postmortems. Most of the times, new Nagios checks are the ones, are the most common action items or outcomes of postmortems. I'll actually show you a few slides, couple down the road. But for now, a lot of monitoring and alerting improvements, specifically which are not system specific, actually came out of postmortems. Great. The next slide is a very good example. Remember I talked about blameless postmortems? This is actually a real snapshot of a postmortem process. Why 1, which is like the 5 why process, you ask, okay, why was there customer impact? That's where you normally start. In this specific case, you'll be surprised. There was this is probably one of the biggest mistakes that operations has done for a long time at IMU, is somebody accidentally dropped a table on the master database, and that database was actually the database which is holding pointers to all the millions of stuff that our users upload every day, which is user generated content. Remember, we talked about like 10 plus million items in our virtual catalog. So all that was dropped on the master. And yeah, just the guy did not lose his job. I'm just, full disclosure. So again, the reason I put this slide in here is again, great things can come out of postmortem. So one of the things, if you look at like why the table was dropped, a day before, the person was actually working on the master. He logged in as root, just because it's easy to log in as root to the MySQL. Most people do it. I do it. I used to do it. Not anymore. But then again, sometimes you learn things the hard way, right? So, and then he had the terminal open, and then next day he came back, and he thought he was on a different terminal, where he was like working on setting up a different machine, and then he accidentally issued that drop command on the master, on the wrong terminal. And then we said, okay, that's fine, shit happens. But what can we do about this? So we said, okay, why did somebody log in as root? It's just because there's no easy way to log in as a read-only user. So we said, okay, let's make it frictionless to for somebody. Just all they have to do is just run one command and just provide the host name, and they're log into MySQL from anywhere as a read-only user. We did that, and now everybody is just. Previously, you had to know the host name, you had to know what role it was, you had to know the password, and all kinds of stuff. So we said, okay, if you make it frictionless, people are going to use it. I think that's the trick. If you also look at some of the other action items, again, we said, okay, no user should have drop privileges. And then if somebody needs it, give that user drop privileges temporarily, and then take it back. Again, this is, just an example of how things happen at IMU and why it is so critical to actually, to understand, why it failed, and then to prevent, future action items. If you remember, I also talked about the fact that at IMU, we don't just monitor things like load average and CPU usage. There's a lot of business critical and business and application metrics that we monitor. If you look at these specific examples from our Nagios, there's a host called counters. I mean, obviously, there's no host. It's just a fake name. And there's a host called alerts. If you look at some of these examples, you'll see that we monitor things like, again, I already talked about registrations, revenue, logins, but you can also do things like, if you dig down, like how much money we made from PayPal every day. Or let's say there's a game, and let's say you're inviting somebody, you can actually alert on how many times that a user is actually inviting other people. Because everything at IMU is a counter or a fact. Again, this goes to the Devops thing, where there's this huge collaboration between the operation and the engineering team. And when an engineer or developer writes code, for every server-side metric, it's a counter. By counter, what I mean is it's a simple, it's a key name and a value that we store in Memcache. For example, let's say you're not able to connect to your master database. Okay, so we call that a tep die, just a key name. So each time this happens, we increment that counter. So, and we have, I don't know, thousands of counters. If you look at these, for example, there's the cyber source. I don't even remember this. There's so many. We have translations, prepaid cards. So every failure, every success is actually incremented. So there's tremendous instrumentation in the code. So when you write something, it's part of the culture to actually write, to make sure that there's counters for everything, or facts, what we call as. A fact could be simple as, let's say there's a new game that we are pushing out, and let's say somebody clicks on, Meet Me or something. Let's say there's an imaginary thing, Meet Me. That's a fact, and that's actually recorded in our database. A counter is more something like an actual, as I mentioned, you're not able to connect to in a Memcache instance, for example, and that's, you actually increment a counter. Again, you can look at this in more detail, but the slide has been put in there just to illustrate and demonstrate that you should be monitoring business and application level metrics and not just server specific metrics. How many people know what load average here? What load average is in this room? Great. I think load average is a meaningless number. Why? Just because there were so many times in my experience where somebody comes to me and say, hey, the load average is 5, the load average is 50, 60. So my question then becomes, okay, so what host is this on? And it says, okay, it's a database. So why do you think it's a bad thing? And I said, no, the load average is high, that's why it's a bad thing. And I said, okay, so it's a database, it's a service, so monitor, like, what is the main role of that service? It's to serve requests, right? Which means, you can actually measure the response times. If it's a web server, you can actually measure the response times of the web server. So again, this is something that actually came out of 5 processes where we were like, not monitoring what we were supposed to be monitoring. And we said, okay, let's actually start monitoring things like response times. In fact, I'm such a huge fan of response time that if you actually know what your service is, if you know it pretty well, and if there was one thing that I wanted to monitor, not all these 20 things, and that would be response times. Because no matter what happens, ultimately, I mean, if your application is serving requests reliably, that's like the biggest thing that you probably care about. Great. Have people in this room heard about iStatD by any chance? No. Okay. Part of the, again, continuous deployment philosophy, or the part of the infrastructure that is needed for continuous deployment is you need to be able to do continuous monitoring. Again, we had the push system, we had the automatic push monitoring and rollback, the cluster immune system, and things like that. One of the things that was difficult for us to do at Imbue, specifically with Nagios and Cacti, was the fact that, for example, how many people use Cacti in this room? Great. Any complaints? Like, what is the biggest complaint with Cacti that you guys have, or no complaints at all? Yes. Cannot automate it? Okay. Which means like adding graphs and things like that is difficult, correct? Okay. Any other complaints with Cacti? Great. One of our big complaints, I mean not big complaints, I mean it's just the fact that that's how Cacti is built. It's based on RRDs, which means you can only have like 5-minute resolutions. Which means if there were like 2 or 3 changes that happened at the same time, you just don't know what happened first. There's no way. You're just guessing. Because let's assume when Cacti polled for that data point, it could have been pushed at 220 or 225, and then you just take a guess. So you're like 80% sure about which change went first. We said no. And then of course the fact that adding graphs automatically, it can be a challenge. We did do some hacks, like major hacks, although we didn't like it. So we can have, we do have the ability to add graphs using just a command to Cacti. But again, we're not, it's still painful. The whole process takes a long time and things like that. But anyway, iStatD is something that was built by Imbue. It can do things like sub-10-second resolution of data. It actually has an API. One of the other things that Cacti doesn't have is if I asked you, yes. Okay, if I asked you how much, what was the load on a machine at 225, for example, you would have to go to the graph and you would have to zoom in and do things like that. But with iStatD, you can actually query all that data. It has the ability to stack multiple graphs on the fly. It also has long retention time, which means you can store data for like a long time. And most importantly, it's being released as open source this week. Go and check it out. I think it's on GitHub. And feel free to check it out. It's also based, like I think the UI, the front end UI is based on Graphite, but you should check it out. This is an example snapshot. If you actually look at the bottom, it shows you the 10-second resolution, and this was not possible at all. And you can actually stack graphs on the fly, and I just showed you an example of like 3 different memcache hosts and things like that. What is really cool about iStatD is just imagine if you were a developer and you pushed out a new counter and you pushed out a change that went to like 1% of your customers. In real time, in like 10 seconds, you can actually see that counter is increasing in iStatD. So it is really cool. Since I only have 5 minutes, The last section I really want to talk about was, you should have a strategy for monitoring and alerting. How many people in this room have a strategy, or at least think they have a strategy for monitoring and alerting? Only he. Okay, what is your strategy? Monitor all the things, because I remember you mentioning, things like, there's too much, it's spam from Nagios, right?
Yeah.
Great. I mean, did you guys look into any strategy around trying to fix that, or you just?
Yeah, we try to roll things up.
Okay.
Decrease the re-nagging threshold.
Okay.
Although that can be a feature too. If you hit snooze enough times, eventually, if you get annoyed enough by it, you'll actually do something about it.
Got it. Anyway, real quick, just 2 minutes. The human element of monitoring and alerting is huge. We also do Nagios and TDD, which is the test-driven development. I kind of talked about it when I did the operations commit. Remember when we commit the host file, there's a bunch of tests that run. So again, it's about when you have Nagios, make sure you have tests for it, like automated tests for it. Invest in it, and trust me, it's worth it, rather than trying to stare at the screen and saying, okay, did this fail, did that fail, checking things manually. I think this is a much better, unscalable approach. Decouple Nagios. I'll talk about these, but since I'm running, short of time, the human element is have zero tolerance towards false positives. I mean, zero. Do not let people develop immunity towards pages, because if you let them, hey, this is this page, it came in at 3 a.m. I know it. I've seen it before. Do not let that happen, because if you let that happen, what is going to happen is pretty soon you'll have your ops team come in as zombies to the office next to you, just for no good reason, just because they were dealing with a bunch of false positives. And pretty soon, what is also going to happen is they will start to ignore real failures. So always have a policy saying that don't deal with false positives. And the other important thing is make sure that all pages are actionable. So if you get a page, make sure that it is actionable. It is really actionable. If somebody says there's no action, it should not be paging. Just turn it off. We also have something like automatic enabling of alerts, because it's easy for human beings to forget. You disable a notification for a service, and then you forget about it. Who's going to turn it back? Nobody. And then 2 months down the lane, there's a P1 or there's an issue, and then if you sit in the root cause analysis meeting, they say, okay, why did this page? It said, okay, I disabled this alert 2 months ago. You don't want that to be happening. So again, it is important to build a system which can automatically turn alerting back on for you. Here's an example of what we do to what we call as the daily triage. Again, just to get rid of the false positives. TDD, I kind of talked about this, adopted heavily by ops. It's a sample test output that you can look at. I mean, you actually get the slides and such, but again, this is a great example of one single check has 25 tests to it. So this would ensure that it actually has tests for things like Nagios latency. Can you imagine that? So even if there's latency, you're guaranteed that your check will do what it's supposed to do. Decouple Nagios is kind of how many people still use SSH to for you let Nagios run SSH commands on remote hosts? How many people do that? It's not a very scalable thing, because again, Nagios is not really good at that. I mean, it's not meant to be doing SSH. I mean, so if you decouple Nagios from that processing, you can actually scale Nagios to really well. For example, we have 18,000 plus checks on a single instance of Nagios. Why decouple? Again, for scalability and efficiency reasons. Really, I mean, my main goal, for this presentation was, again, to expose to you. It was going to be tricky, because again, I'm trying to consolidate 5-6 years of experience in 15 minutes. So it's kind of tricky, but I hope I gave you guys at least some insights into what Nagios is, and especially in a continuous deployment shop like Imbue. And then never underestimate monitoring and alerting. I think it's a critical thing. Trust me, for things because I think this is going to be important. Let's say you have backups. How many people have backups here? How many people actually audit their backups? That's great. 2 people. Great. So again, You could be in situations where you have a master database, you have a standby, and if your standby has a specific rule or something, and for some reason it has replication filters, whatever, and it's ignoring certain databases from replicating, and you cannot catch things like that, and like 1 year down the lane, you go to your backups, you have backups, but then if you're not auditing them properly, you'll be in like big mess. So again, monitoring alerting is absolutely critical. Invest properly in it. Don't limit the usage of Nagios to just ops. Again, if you remember my rule, if you make things frictionless, people will use it. So even the same thing holds for Nagios. Don't complain too much about Nagios performance because bathroom breaks can take 5 to 10 minutes. So if you're saying Nagios has a latency of 2 minutes, it's okay. Don't don't fret too much about it because just realistically speaking, again, little things can you could be out on lunch, you could be driving. And I wanted to talk more about the predictive monitoring and alerting and things like that. But do remember that Nagios is good at not just Nagios, but any tool is at least in the way that most people use is good for like static thresholds. But if you want to catch hey, the reads on my database jump by 20%, you need to build some form of predictive monitoring to catch that. Finally, Nagios has been absolutely reliable, like a Honda. 8 years, I think we've used it, never once died on us. I think huge kudos to the Nagios team for that. That's it. I don't know if I have time for questions, but thank you. Hopefully, it was a decent presentation.
How about a nice big round of applause? One more time for Kishore Jalleda.
Thanks, guys.